So next thing we're going to see, that is circular linked list. Okay, so what this linked list is. So in this type of linked list, actually what we do is the last node of the list has the pointer to the first node. It means it's going to make a circle, like, so it does not have a beginning or an end. So but we can take the head and the tail of that, right? So we'll understand that what I'm trying to say. So in this circular link, go around the nodes until the program reaches the same node from where it started. So we're going to take suppose head is there, and it's going to go, and we're going to take this node as the tail, and until unless it reaches here, we're going to say that it's a circular linked list. Okay, so what are the usage of circular linked list? So it's useful for the implementation of queue. So it's used for the implementation of turn-based games to decide which player is about to be played once the player finishes his turns to move its player. So you might have heard the Robin algorithm and stuff. So that is also done by circular linked list. All right. Now, few techniques are there. There is going to be two techniques, two-pointer technique. A technique for which a pair separating data find range in sequence or finding even in cycle in a linked list. So we're going to see this thing also and compare the value of two pointers. The most famous usage of these are fast and slow start and pointer technique. So that is what two pointers technique. Next is we're going to see the sliding window. So use one pointer and other variables for the window size to find the within the sequence. So it's used to check what data is included between two pointers and not just the data at the two pointers themselves. So we're going to see this thing also. So that need only one pointer that shows the start of the subpart and an integer that indicates the size of the subpart. Now we're going to jump to the whiteboard and we'll understand what this circular linked list means. After that, we're going to jump to the VS Code and we'll implement the circular linked list. So let's jump to the VS Code and let's understand what that circular linked list mean actually. So here we're going to see that what this actually circular linked list is going to do. So that we're going to implement here. Okay, so circular linked list, you can see if this is the head node, we're going to mark it as a head node. This node we're going to mark it as tail. All right. So you can see it is connected to here again, right? When a list has more than one element. All right. So when let's say list is empty, so that time what will happen actually, right? So that is the question. So you can see that when the list is empty, that is going to be tail and that is going to be head only. And what is going to there is it's going to come back to itself. So if this is head or tail, whatever, head dot next, that is coming back to head, isn't it? So this is what the connection is. So this is we're going to see and implement also. So let's go ahead. Okay, so suppose you want to enter element over here. So what you have to do? So for entering the element, what you have to do is you have to remove this connection and make the connection here, and this null will be changing to this one, right? This is what you do. So the current next is going to be the temporary node and temporary next is going to come back to current. This is what the connection insertion in a linked list. All right, that is circular linked list. Okay, let's go ahead. What things we see, that is the insertion. There is no like entering at the head, or you obviously can do it. We'll obviously do it entering at the head, entering at the tail, and entering at the position. Similar fashion that we did the single linked list and double linked list. All right. Now for the deletion purpose, if you see, suppose I want to delete some element. All right. So that is, let's say delete element from the head. If we'll check if that is only one element is there or not. If only one element is there, we're going to make it as null, right? Because there nothing will be there. And we're going to, when you go to delete from the tail, we again will check if one element is there or not. If more than like one element is there, we have to make it after deletion, we have to make it null. And after that, we have to do it. Now, if suppose you want to delete from any middle part, then what you have to do, suppose you want to delete this one. So what you have to do is you have to make this connection this way. Suppose you delete the last element and like lots of elements are there. So what you have to do, you have to make this connection here. It means you iterate to this position, and after that you have to make it here. So you'll take one node, and that's going to iterate from here to this 30, and that next is going to come back to head again, right? That is what we would do implement. So let's go and jump to the VS Code and try to understand the implementation of that. After that, we're going to solve good questions, very good questions. We're going to solve one by one. So let's jump to the VS Code. Now we jump to the VS Code, and here we'll do the implementation one by one. So I'll go over here and I'll click it here, and I'll write cll.java. So this is a circular linked list. All right, the class has been created. I'll take it down, and what I'll do is I'll delete from here, and I'll delete these things one by one. Okay, so we're going to implement this circular linked list by singular linked list only, right? We're going to do that singular linked list, and we're going to implement the circular linked list. All right, so here we have to write the class. That class is going to be circular linked list. Okay, now inside this, we already know that we're going to create nodes and stuff, data member function, each and everything we're going to define. So we have to do one by one. So here we're going to do inner class representing, I have to create the node, right? So inner class representing a node in the circular linked list. Okay, now what I have to do is I have to create a class of node type, and in this I'm going to create what? I'm going to create the data members of that class. So for that node, what is going to be there? It's going to definitely going to be data is going to be there into data. So we are implementing with singly linked list, so we're not going to take previous for that. So I'll write one more data member that is going to be public, and its type is node, data type is node, and I'm going to write next. Okay, these two data members we are taking, we want to not take previous, because we are doing what? Implement using singly linked list, like so data stored in the node. This is what? This is a reference to the next node. Okay, this much is done. Now I have to create a constructor to create the node, right? Constructor to create a new node with given data. So to create the constructor, we have to write, what is the class name? Class name is going to be definitely going to be node. And okay, what I have to give is I have to give the data in it also, right? Int data is going to definitely going to come, and okay, now it's good. So this here we'll write this dot data. This dot data is going to be data, and we are writing similarly to the singly linked list only. So this dot what next is equals to null, because next is initially pointing to null. So this is the inner class node we have created. All right, now let's come out of it here, and I'll create global that is data member for the circular linked list class. So what I'll do is I'll create node head, I'll create head, and I'll create tail also. So we're going to implement that similar way that we did. So only few things I'm going to change, and that's going to be there. All right, this is reference to the head, that is the first node. Okay, I'll write it, reference to the head, that is first node actually. All right, that is first node, and here is going to reference to the last node, reference to the last node, reference to the tail node, that is last node. Okay, this much we understand. All right, so we have to create constructor for that also. So I'll create constructor to initialize and empty circular linked list. I'll click over here so that I get more space. Okay, now so I have to create constructor. What is the name of the constructor? It's going to be, constructor name is going to be circular linked list only, because we are writing in that class. So circular linked list, and inside this constructor, what is going to be there? This dot head is going to be head, and this dot tail is going to be, okay, we are creating constructor, so it's not going to be head. We are creating empty, right? So I have to write null here. All right, so it is getting null here. Okay, now this much is clear. Now we will do method to insert a new node at the head of the linked list, circular linked list, right? So here I'll come out of this constructor, and here I'll write, this is the member function. We will start to write method to insert a new node at the head of the linked list, head of the circular linked list basically. All right, you already know what I'm going to write. I'm going to write public data type of return type of that function, that's insert at, right? Insert at head, I'm going to write, and I'm going to give data as the input. Okay, now I'll create the node. All right, node, new node, I'm writing new node equals to new and node, and I'm going to pass data in it. So this is the creation of the new node. Now I'll check if the head is null. If the head is null, so for the first node, I'll be set it to the reference to itself only, that we talked about, right? If head is null, I'll check if head is equals to null. So what I'll do is I'll create that node and I'll reference to itself only. So how to reference it? New node next, new node dot next is going to come back to new node only. That is, I'm pointing to itself again. All right, and I'll update the tail equals to new node, because tail is also that same thing, because only one node is at that time. Tail is also same thing, and head is also the same thing, right? Here what I'll do is I'll write it. So for the first node, set its reference to itself. Okay, and this is what we're doing is we are updating the tail, update the tail to the new node. Okay, this much is done. Now I have to write if the head is not null actually, right? So what I have to do is what I'll do is new node dot next is going to head, right? We are entering at the top, right? So like in front of the head, right? So we are going to connect it. This is the connection we are doing. This is what set the next of new node to the head. Okay, after doing this, I have to connect the tail of that linked list to new node, because it's a circular, right? So I'll write one more thing, tail dot next, that is going to come to again new node. It is what? Update the next of the tail to the new node. Okay, this much is done, and at the last what I'll do, I will update the head also, because head also need, because insertion at the head we are doing, so we have to update the head every time, right? So new node, so this will do what? update the head to the new node. So new node will become the head now. New node. Okay, this is insertion at the head is done. Okay, now we're going to go forward with the next member function. So method to insert a new node, at the tail. Suppose we want to do this, so what I'll do is I'll write, function. I'll create public void insert at tail. All right, so insert at tail I'll do, and in this I'm going to pass the data. Okay, now I'll create the node first. So I'll create node, a new node I'll create, and that's going to be new, and node I'm going to pass data in it. Okay, node creation done. Now what I have to do is I have to check if the tail is null or not. If it is null, then I'm going to reference back to itself only, right? So I'll check if same thing that we head equals to null, we did same thing, we will do it here also, tail equals to null, right? If it is null, what I'm going to do is new node dot next is going to come back to new node only, right? And what I'll do is I'll update the head, and the head is going to be what? New node only, new node. Okay, I'll write it for you guys also, that what actually this means. So if you revise, you should not get any kind of problem. So for the first node, set its next reference to itself, and for the this one, this is what? Update the next of the tail to the new node. Okay, if the linked list is not empty, like it was not empty, right? So what will done? New node dot next is going to come back to head, and tail next is going to go back to new node, right? So what I want to write is new node dot next, that is going to get back to head, right? And what I'm going to do, tail dot next is going to new node. What I did, if I go over to this whiteboard, you'll understand better. So what we're doing is, suppose we are entering the new node here. So what I have to do is, this is tail. If this is tail, so tail dot next is going to be connect here, and this is new node. So new node of next is going to be connect here. Sorry, I'll just remove this, so this will remove the confusion. Okay, so suppose this new node I am entering, right? If this is tail, so tail dot next is going to connect here, and new node is going to next is going to come to the head. So that is what actually we are doing. So if you see over here, we are writing tail dot next equals to new node, and new node dot next is going to go to the head. All right, so what is this? This is the connection. So set the next of the new node to the current head. Okay, and this one is what? This one is update the next of the tail to the new node. Okay, this much is done. Now I have to, at the last, I have to update the tail also, because we are doing insertion at the tail, right? So I'll do new node. So this is what? update the tail to the new node. Okay, so this is insertion at tail is done. This method is done. Now we're going to insert at middle, like at the specific position, right? Method to insert a new node at a specific position in the CLL, circular linked list, right? So what I have to write, I have to create the function for that. So public void insert at middle, suppose this function, I'm going to give the position and data, right? Int position, what position I want to give, and int what data I want to insert. Now for this, I have to check if position is less than equals to 1, then you have to insert, you'll call the head, inserting at the head. If position is greater than size, then we'll insert at the, that already is same thing we're going to do here, right? That we already did in the WN circular linked list. We're going to write position is less than equals to 1, then that definitely is going to be the insert at head, right? So insert at head and data we're going to do. All right, this is what if position is 1 or less, insert at the head, insert at the head. Okay, now else if, one condition I'll write here, that is if position is greater than size function. So this size function will again define, right now it's not defined. So if it is at the last, right, so insert at the tail, it means, isn't it, greater than size means insert at the last, right? This, what does this mean? If position is greater than the size of the linked list, size of the list, then insert at last, that is insert at the tail, right? Otherwise we're going to insert at some position, right? So here we're going to create, let's say we want to get the node, so we'll write node, I'll create the node, new node I create, and that's going to come to new node and data is going to be there. Okay, you are entering at some position, right? So what I'll do is I'll take one temporary variable that will be, that's going to iterate and is going to go to that position. After that it's going to take the value. So what I'll write is I'll take node and temporary, so this node has to be capital N. Okay, so I'll come over here and here I will be taking temporary node, temp equals to, and that will be pointing to head initially. All right, and what I'll do is I'll take count equals to 1, count equals to 1, and I'll write a while loop and will go to that position first, then after that we'll enter. If count is less than position minus 1, it will reach to that position. So how to reach that position? We'll iterate every time. Temp equals to temp dot next, this is going to iterate, right? So this is what actually traversal of the list. Okay, if it is going over there, okay, spelling is wrong, that is going to be POSI position, and here I have to write what, count plus plus, I have to increment the count also. After reaching that position I have to enter the node. Okay, so let's suppose here we reached, let's say this is the temporary we reached, right? Here we want to insert. So if suppose I want to insert this, so this has to be connected to here and this has to be connected to here, right? that is the insertion right at the middle. So this is what new node. So new node, if this is temporary, this is temporary dot next. So here this connection will be writing as what, new node dot next is going to equals to temp dot next. Now what is this connection? This is temp dot next is going to new node, isn't it? Temp dot next is equals to new node. This is going to be there. All right, so we will write that thing only here. Okay, so I'll write new node dot next, that is going to temp dot next. This is what, set the next of the new node to what, to the next of the current node. What is that current node? Temp. Temp is that current node. Okay, here what are you going to do? Here we're going to write temp dot next. We're going to write what, new node. This is what, update the next of current node to the new node. Okay, this is all done for the insertion at the middle. Now what I have to do is I'll create a member function for method to delete a node, right? So we'll write method to delete a node, and in this everything will be covered. So if, okay, before that we'll create the function. So I'll write public, void and delete node, and I'll write int, let's say from which position I want to delete it, right? That position I reached. And what I'll do is if position is equals to 1, it means we are deleting from the head, right? And we'll check if head is equals to tail, only one node is there or not, we're going to check. So I'll write if, because multiple conditions can be there, right? So we'll cover all the conditions, right? If head is equals to tail, it means if head is equals to tail, it means what? There is only one node. So what I'll do is I have to delete it, so I have to make it null, and I'll make tail also equals to null. Okay, so what does this actually mean? If there is only one node, set the head as null. Okay, and we will set tail equals to null also, and set tail also as null. Okay, that's great. Now if more than one element is there, so that is going to be covered in the else. If more than one element is there, what I have to do? Okay, let's jump to the here. Suppose we want to delete, like we are deleting from the, like suppose we want to delete this one, head, right? So tail dot next is going to come to head, right? Before that I have to move this is going to be the head, right? I have to delete this one. Right now this is head, so what is the name of this? This is head dot next, isn't it? So what I'll do is I'll update the head first, and after that tail dot next is going to be connected to head. Tail dot next is going to be connected to head. All right, so what I'll do, first of all I'll update the head, because after deletion head is going to change. So head is head dot next. This is what update the head to the next node, because deletion is being done, right? And after that, tail dot next is going to connect to where? Tail dot next equals to head. Why? Because this is the connection, right? So update the next of the tail to the new head, right? Isn't it a new head? New head will write. Okay, this is deletion from the head. Two condition is there, so that is done. Okay, now let's suppose we want to delete it from the middle or last. For the singular linked list, we saw if you want to delete from the last and middle also, that code is going to be same, right? So here we're going to write it in else. Okay, in else, what I'm going to do is I'm going to create a node that's going to be cur, and that's going to point to head. All right, and we'll take one more node that is going to the previous, exactly same thing we will do that we did in the singular linked list and doubly linked list. So here I'll write count is equals to 1. All right, and I'm going to iterate through the while loop. We are basically going to that position where we need to go. So if count is less than position, if count is less than position, till that time I have to go and I'll write previous equals to cur, and I have to increment the current, right? I have to traverse it. Cur equals to cur dot next. This is what? Traversal the list to find the node to be deleted. Okay, this is done. Now what I have to do, I have to increment the count also, count plus plus. Okay, this is done. After reaching there, what I have to do is I have to do the connections, right? So let's suppose, go over here, let's suppose, let me clear it first. Let's suppose we want to delete any middle element, and we'll see for that element deletion from the last also how the both code is same, that we're going to see. Let's suppose first delete from the tail. Suppose we want to delete this one, right? Now we reached over here, isn't it? We reached over here. So what we have to do is, we have taken a previous, this is going to be the previous, and this is going to be the current. Current is that node that is going to be deleted, and previous is that node, that is we are at two nodes we created, right? So this node has to be deleted. It means previous next is going to be connected, previous next is going to be connected to what? Current next. Current next is what? This one. So this is going to get to here, right? This is going to be going here. So previous next is going to connect to current next, right? And if current is tail, for that we'll update the tail, right? Right now it's current is tail, so we have to update the tail also for that. If you're deleting from the middle, we don't have to update it, right? So that is the thing we want to consider here. All right, so what I'll do is, here I'll write what? Previous dot next, that is going to connect to current dot next. For the end, like for the tail, this current dot next is going to be null, like that is not actually null, that is going to be head. But every time it is not be head, we cannot write head. If I write head, that is only valid for the tail, right? Deleting from the tail, but we are doing for the both. Sometimes current dot next is going to be head. In what case? That is going to be the when the we are deleting the tail right now. So right, this is what, this is the generalized case. So here what to do is update the next of the previous node to the next of the current node. Okay, this is done. Now I have to check if we deleted the, if like we have to check that like haven't we deleted the tail. If we deleted the tail, then we have to update the tail also. If current is equals to tail, because current is that element we're going to delete it, if that is tail, I'll update the tail, right? And that is going to be previous. So previous is going to be the tail. So if the node bing being deleted is the tail, then updating the tail to be previous, right? This is all done for the deletion. Now what we'll do is we'll calculate the size of the linked list. Now here the thing is there, here is going to be changed a bit. So here we're going to do what, size of the linked list. Okay, now twist here is it's a circular linked list. I cannot write while it's not equals to null, you know, until unless it become null, that time I will run. No, I cannot write that until a node becomes null, isn't it? Because there is no null in it. So what is going to be there? It's going to be again, you know, looping, and we will be ending up, you know, printing lots of times, right? So what we'll do is I'll create public, and it's going to be the integer type we're going to return, and I'm going to write the size function. And in the size function, I'm going to take, okay, we're going to check first if head is equal to null. If it is, head is already null, it means what? Nothing to print, isn't it? So I'll return 0. I'll return simply 0. If head is null, like no need to find the size. So if the list is empty, if the list is empty, then return 0. Return 0 as a size, right? Okay, now let's go into it. I'll write int count is equals to 1. I'm starting from 1. That head node I am considering, that is I already counting. So you earlier you might seen that we have written count is in case of size function. If you remember, I'll just go to that, count equals to 0, because head we don't used to consider that. Now right now we are counting that head as 1, like we thought that we already counted. Okay, now what I'm going to do is I'm going to take temporary node, and that's going to start from head.next. If you remember, we used to do what? We used to write node.temp is going to start from head. That's why we're going to write 0, right? Here we are doing what? Here we are doing temp.node temp is head. And here we are writing 1, we counted, that's why you're going to head from head.next temp is, you know, actually it's going to start. What actually mean is, if I want to find the size, this is I'm considering is 1, and here is the temporary variable actually is there. From here it is starting. So what you're going to do is this is going to be there, this is going to iterate, and when it will reach again this head, that time will cross the, you know, we'll say that we already, you know, looped it. Let's see how I will write the logic. All right, so what I'll do is, while temp is not equals to head, see, not writing null. Previously what we have written, temp is not equals to null, right? Because in circular linked list no null is there. Temp is not equals to head. Now I'll say, people will say that head, why you're not taking the, how will print the, you know, how will find the size? Because we started from 1, you can see over here, right? What I'll do is I'll do count plus plus, this will increment the, this is increment the counter for each node. right? And we're going to go to the next, that is temp is the temporary node we have taken. So temp dot next is going to go to the, like, this is traversal, traversal, traversal of the list. Okay, so here it's going to be what, it's going to be temp. This is done, and at the last we go to return count. Return count, this is the size function. Now in printing method also same thing we going to use. In printing also, method to print the circular linked list, we're going to print the data of the node, right? So what we're going to do is we're going to check again. Okay, before that I'll write the public void print, and if head is equals to null, if head is equals to null, what I'm going to do is I'm going to write system dot out dot println. I'm going to say head is null means circular linked list is empty. I'll say it is empty, no need to it print it, right? And I'll return back, return, simply writing return. All right, I'll come out of this if, then here I'm going to create one node, and that's going to be temporary, we're going to take, and that's going to take from head. Okay, now here what I'll do is I have to run once, like this head I need to print once the data of it, but after that I don't have to, right? So you remember do while loop is working that way, right? Do while loop I'll be writing over here, do and while loop. In do while loop, if the condition is false also, it will run once. What is going to be the condition? Temp is not equals to head. The condition is definitely going to run once, because here I'm going to write what? System dot out dot println, and in this what I'm going to write is temp is the node we have taken for the iteration, dot data is going to print, and I'll add it and I'll give some space to it, and I'll come up. Okay, here we'll not write println because it's going to go to the next line every time. All right, so this is after printing, what I have to do is I have to iterate also. So I'll write temp equals to temp dot next. Okay, this is what? Traversal of the list, traversal of the list. Okay, and in while loop this is written as continue. This is going to be continue until the traversal reaches the head again, because it is starting from the head. You can see from here it is starting from head, and it's going to go till it's running till head again. All right, because one time it's definitely going to run, and after coming out of this, what I'll do is I'll give one enter line over system dot out dot println, a simple enter I'm going to give. Okay, now one method is left, that is the searching method for searching a value, method for searching a value. Now I have to write the searching function. So I'll write the searching function as public boolean function we're going to create, and that's going to be the search. Okay, and here I'm going to take int value, int value. In this I'm going to check if the head is null. If head is null, no need to search it, isn't it? Nothing is there, so return false, return false. Okay, So if the list is empty, return false. If the list is empty, return false. Correct? Now I'll come out of this and I'll go over here. I'll create a node, and that is going to temp, and that is going to pointing to head again. All right, and for searching again, I'm going to write do while loop. So do, I'll come out of it here, and here I'll write the while loop. Okay, and condition is definitely going to be there, that only temp is till not than equals to head, because we cannot not write null, right? Now here we have to write the thing. If temp dot data is equals to value, if temp dot data is equals to value, that time I will return true. Return true if it is there, right? Like if, what it means, if the value is present at the list, this is the meaning of that. And what I'm going to do is, after here I have to iterate to it also, temp equals to temp dot next, so that it will go to the next line every time. So this is traversal of the whole list. Okay, after it is done, I have to, if it is not found, so what I'll do, return false. If it is not found, if value is not found, return false, right? So this is going to be the searching function. Now I'll come back over here and I'll go back, and here I'm going to write the main method. So we're going to write, public static void string array and args arguments. Okay, now we will create the object for the circular linked list, right? Circular linked list is equals to new circular, control Z, circular linked list, and this is the object creation done. Now I have to do insertion at the head, whatever the operation we did in the singular linked list, same operation we're going to do these things. So we're going to apply 10, 20, 30, 40, 50, then we'll have like all the same thing we're going to do. All right, so here I'm going to write circular linked list dot insert at head, and suppose we want to insert 10 over here. Okay, so after entering 10, I'll write circular linked list again, and I will call the print function. So print function called, I'll hit Control S, save it, and I'll run the code, and we will see that it is printing the 10 in it. Okay, it did. Now what I'll do is, I'll just copy and paste it 3, 4, 5 times. Okay, 2 semicolon I have used. I'll be pasting 3, 4, 5 times. Control C, paste it, paste it, paste it. Okay, so okay, it has to be in the proper indentation. Okay, here it has to be 20, then this has to be what, 30, this is 40, same, whatever we have taken that example, we're going to take that same values. Here we're going to write, let's say 50. I'll hit Control S and I'll run the code and see if it is at the head, it is entering or not. Yes, it is entering. Now what I want to do is, I want to insert at that, like after 10 I want to insert, let's say. So what I'll do is I'll copy this and paste it over here. So insert at head, instead of head I'll write insert at tail, and here let's say I want to insert 20 in it. Okay, and I'll copy this, control C, and I'll paste it over here. Instead of 20 I'm going to write 30. All right, and I'll again paste it, so that 3 elements I add at the last. Okay, instead of 20 I'm going to write 30. So this 3, this element should be, I'll hit Control S, I'll go over here and run this code again. So it's okay, 20, 30, 40 I have to write, right? So 40 I'll be writing, not same value. Will give Control S, and I'll go over here and run the code. Okay, suppose 20, 30, 40 is entered. Now suppose I want to check the head, right? So I'll write what? System, that same thing I'm going to do, system dot out dot println, and here I'm going to write what? Head is going to be what? I have to come out of it, and I have to write circular linked list dot head dot data. That is going to print the head, right? So I'll print this, I'll copy this, and for the tail same thing is going to be there. Paste it over here. Instead of head I'll be writing tail, and instead of head I'll write tail over here. Okay, now what I'll do is I'll hit Control S. Now I'll go over here and run the code. So you can see 50 is the head and 40 is the tail that is getting printed. Now I'll do insert at the middle, circular linked list dot insert at middle, right? We'll see that also if that is working or not. Insert at middle, for the first position will enter that 200 we used to enter, if you remember. So I'll give 200 over here, and it's going to enter the 200, right? And after that I'm going to check the head and each and everything. I'll come over here and paste it. Like, I'll hit Control S, and I'll go over above and I'll run this code. So it is printing head is now 200. Now let's suppose I want to give, I will copy this again, and I want to enter at the 10th position, that is at the last. Okay, instead of 200 I'll give 100, that we took 100, if you remember. I'll hit Control S, and I'll go above and I'll run the code. Hundred is added in that, so you can see tail is also getting updated. Okay, now let's suppose we want to delete it and we want to check it. So I'll do a circular linked list, dot delete node, and let's suppose we want to delete the first node, and we need to print it, right? So I'll write circular linked list dot print function. Okay, I'll hit Control S, and we're going to go above, and we're going to see if it is deleting the first, that is 100 is getting deleted, or 200 is getting deleted or not. Yes, 200 got deleted and 50 got updated to 50. Let's say I want to delete from any other position, Control C, let's say any, I give 8, from 8 position I want to delete. So what is the 8? 1 2 3 4 5 6 7 8, 40 is going to be deleted. It means I'll hit Control S, I'll hit Control S over here, and I'll go and run the code. So 40 needs to be deleted. You see 40 got deleted. All right, now this is deleted from the position, is done. Suppose I want to see the size, so I have to declare one variable, that is size. I have to store it over here, and I'll call that circular linked list dot size function I'll be calling, and I'll be writing system dot out dot println, and here I'm going to write size of the linked list is, and that is going to give the size, and we have to concatenate it, and I have to concatenate and give this variable size. Okay, this will give the size. Now I'll search it at the same time only. So I'll write system dot out dot println, let's say search over here. Let's say in this I want to search 200, if 200 is present there or not. Search 200. All right, and I'm going to go to, I'll concatenate it, and I will call the circular linked list dot search method, and in this we're going to give the value as 200. So it will say true or false. It's not there, so it's going to definitely going to give false. And if I copy this line and again paste it and hit Control S, instead of 200, let's say 50 is there or not. Yes, 50 is there, so it should return true for this. So I'll write 50, and here I'll write 50 over here. Now I'll hit Control S. Now I'll go above and run this. So it is using that 200 is not there in this linked list. This is the updated linked list, and 50 is there. So this is the whole code for circular linked list. Now what we're going to do is we're going to jump over the coding part of this linked list. We're going to solve tons of problems from the lead code and other sources, and we're going to see how the implementation is going to be done. So this is all about the circular linked list. Thank you.